Hi, welcome back to Moose and Chemistry. This is Molecular Empirical Formula lesson number 13. Let's look at the problem. A compound contains 12.8% carbon, 2.1% hydrogen, and 85.1% bromine. What is its empirical formula and its molecular formula when its compound has a molar mass of 188 grams per mole? It's also very, very important to remember that 1% is equal to 1 gram. Okay, so now let's look at our carbon first. So we take 12.8 grams of carbon divided by carbon's molar mass, which we find on the periodic table to be 12.01 grams, okay, per mole. So that will be for carbon. That will give me a molar ratio of 1.07 moles. Pretty cool, huh? All right, so now let's look at hydrogen. Now, hydrogen has 2.1% on the problem, so that means we have 2.1 grams of hydrogen divided by its molar mass from the periodic table, which is 1.01 grams per mole. So we're simply going to divide the grams out like we did here. We should do that here also. And that's going to give me exactly 2.1 moles of hydrogen. Pretty cool so far. All right. Now, our last element in this compound is bromine. Now, bromine has 85.1%, so that means it's 85.1 grams of bromine. When you look on the periodic table, bromine has 79.90 grams per mole. So 79.90 grams per mole, of course. And the grams will cancel out. And that will give me approximately 1.06 moles. So far, so good. So now we've got 1.07 moles, 1.06 moles, and 2.1 moles. So we're going to take the smallest unit, which is 1.06. So for our carbon, we're going to go 1.07 divided by 1.06, and this of course is moles, and there's moles again, so moles will cancel out, and for carbon that's going to give me 1. Okay, for hydrogen we're going to take 2.1 moles, this for hydrogen here, divided by 1.06 moles there, and that is going to give me 1.98 moles, and that's approximately 2, so we'll just put a 2 there. And last but not least, our bromine. We're going to put bromine right up here. So bromine is going to be, of course, 1.06 moles divided by 1.06 moles. And of course, moles cancel out like we do in the other ones, so just like this. And that's going to give me 1. All right, now, so our empirical formula in this case is going to be C, because that's 1, H2, because we have 2, Br, that's going to be the empirical formula. Now, what about the molecular formula? So what we're going to do is we're going to have to erase all this here and give us some more space. So let's go ahead and erase all this real quickly. And we'll write that chemical formula again. No big deal. Okay, getting all that erase out there, yeah. Sometimes these problems can go a long time, but they're always kind of cool to watch and have fun with. All right, so now let's go ahead and do this again. All right, so now remember that our formula was CH2Br. So now we want to find the molecular formula. Now remember, the empirical formula is in the simplest whole number ratio, but the molecular formula is not. So our molecular formula has a mass of 188 grams per mole. So what do we have to do? We have to figure out the molar mass of CH2Br. How do we do that? We do it like this. Carbon is 1 times 12.01 grams per mole. We get that from the periodic table. Hydrogen, we have 2 of those, 2 times 1.01 grams per mole. And our bromine, of course, is going to be, we have 1 of those, 1 times 79.90 grams per mole. So let's go ahead and add all this up real quickly. So we get 12.01 grams per mole. You get 2.02 grams per mole. And of course we get 79.90 grams per mole. And of course our grams per moles are all going to cancel out anyway. Eventually, so this is going to give me a total of what looks like to be, let's see here, my calculator, and we're going to add this all up. Let's see here. So this is going to give me 9, 10, 11, 12, 13. Okay. 3. Carry 1. It gives me 93.3 grams per mole. All right. So now what we're going to do is we're going to divide 188 by 93.33. So we got 188 grams per mole divided by 93.93 grams per mole. And when we do that, so now we're going to take our calculator and do that calculation. And taking my calculator, we get it to be 2.00. Pretty darn cool. So what does that mean? Well, we're going to take this 2.00 and multiply it into the carbon, into the hydrogen, and into the bromine to get the molecular formula. So this is going to be C is going to be 1 times 2. H is going to be 2 times 2. And Br is going to be 1 times 2. Okay? So this is going to give me the molecular formula, which would be C2H4Br2. And that's it. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Musin Chemistry.